Hello and welcome. My name is Regina Sampson, Accreditation Program Manager with IEEE Educational Activities. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Before we begin, please note a few housekeeping items. At the bottom of your screen are engagement tools you can use. All tools are resizable and movable, so feel free to move them around to make the most out of your space. Note that we recommend using a wired internet connection to access today's presentation and closing any programs or browser sessions running in the background that could cause issues. There is no dial-in number for this event. Please make sure your computer speakers or headset are turned on and the volume is up so that you can hear our presenters. You can find additional answers to some common technical issues in the orange question mark help tool at the bottom of your screen. If you have any questions for today's presenters, you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen. We will answer as many questions as time allows. At this time, I'd like to hand it over to Lynn Bowlby.
Thank you, Regina. My name is Lynn Bowlby, and I'm a program specialist with Educational Outreach at IEEE. And thank you for joining us for today's session featuring electric vehicles in cooperation with the Transportation Electrification community. Before we get started, I'd like to do a quick poll question to understand who our participants are today. So if you wouldn't mind selecting one of the items on the screen, I'll give you a moment to do that, and then we'll look at the poll results. All right. Let me refresh my screen real quickly so I can see what those results are. And it looks like a good majority of our participants today are IEEE volunteers and parents, but the majority of them are university educators. And across the board, we have more than 50% who are engineers. So thank you for completing that poll for us. So this month's issue of TryEngineering Together, as I mentioned, highlights electric vehicles. It was developed in partnership with the Transportation Electrification community. And today we'll be speaking with two engineers who have careers working with electric vehicles. First, we have Lee Stogner, Chair Communications of IEEE IoT Initiative and Managing Principal of the Vincula Group. Lee, can you share a little bit about yourself and also talk about the flipbook resource you've provided here?
Thank you. Good morning to all. My name is Lee Stogner, and I'm a very long-time volunteer for the IEEE. Matter of fact, 47 years, and I've enjoyed every minute of it. It's given me the chance to have two careers, one for my day job, and of course, the career for IEEE. So I have been leaders in committees and workshops and conferences, and I've also been a member of the big IEEE board. It has been fun. It has been rewarding, and I have met thousands and thousands of people. So if you're ever interested in doing something that you would greatly benefit from, consider being an IEEE volunteer. So some of the things that we're going to do for you today is help answer the excellent questions that the organizers of this webinar have set up, and at the very end of this webinar, answer your questions. So be ready, jot something down, and we'll be ready for you. What you see on your screen right now is one of our publications for the Transportation Electrification Initiative. It is based on the Flipboard platform, and it allows you to check in every day or so and find out what is really going on in the world of electrified transportation. It's not just about cars, it's about planes and trains and trucks and all kinds of vehicles that are and will be electrified to drive on electricity from a variety of power sources that include lithium batteries, hydrogen, solar cells on top of the vehicle, and who knows what innovative engineers will bring out in the days ahead. So this rather long URL you see on the side of the screen, and I'm hoping that everyone will have access to this presentation. If you click on it, this magazine will come up, and you'll have a chance to see all the articles that, as I mentioned, we collect daily to keep you, the audience, up to date in electric transportation. So one other source of information is our website that you'll see in a little while, and its URL is tec.ieee.org, and you'll see that in writing on the screen when we get there. So today we answer questions, and we help you build your network of people that you know that can help you in your electric vehicle career, and also stay connected to information and other things that we do, such as other academic publications, conferences, newsletters, all kinds of things that we bring to bear to give value to the audience and you students that are out there that are considering education paths and then careers after that. Thank you.
Thank you, Lee. And next we have Sheldon Williamson. He's a professor with the Smart Transportation, Electrification, and Energy Research, otherwise known as the STEER Group at Ontario Tech University. Sheldon, can you tell us a little about yourself and share the resource that we have here?
Sure, thank you. And thank you, Lee, for the nice introduction to IEEE and IEEE TEC's initiative. My name is Sheldon Williamson. I'll be the second presenter today. As Lynn mentioned, I'm a professor at Ontario Tech University up in Canada, in Toronto. My research expertise, of course, I hold the Canada Research Chair position, which is an endowed chair position for research in transportation electrification. Areas of research include power electronics and motor drives. More specific and in terms, we are tackling problems at the heart of transportation electrification. As Lee already pointed out, transportation across the board, which doesn't just limit ourselves to road transportation. We're talking about air, land, sea, space, undersea vehicles, and more recently, the micro-mobility, drones, etc. The key bottlenecks that we answer lie in battery technology, especially limiting the lifetime of cycle life so we can get more range out of it, fast charging of batteries, less than 5 to 10 minutes of charging time, so we don't have to wait almost half a day to charge up a full battery pack for an electric vehicle, and things like that. Also, keeping the batteries healthy at the same time as charging fast. The other cool technology we've been working on with industry is, and I should add, most of our projects are funded by industry, both local and international. So our research is across the globe, not just limited to Canada or North America for that matter, all the way up to shores of Australia and also through Europe and Asia. So we collaborate with the industry. Another technology we've been working on is which stems out of the Tesla coil. And if you ever get a chance to look at this video, I know Lynn has put a screenshot of a video from YouTube. It's a 5-minute long video of our group's activities. In there, you will see a demonstration of a Tesla coil, which was, a patent held by Nikola Tesla from way back in the early 1900s, right? Actually, in the year 1900. So basically, off of that, we've been doing a lot of research on wireless technology, wireless power transfer, and that's something cool, since autonomous electric transportation will be the next wave, so in the next decade or so. So instead of plugging in to charge, you can charge wirelessly or cordlessly. The same goes for flights, for ships, trains, streetcars, you name it. And so, like Lee said, to answer your questions, that's in a nutshell what we do in terms of our research. And again, I've been part of the transportation electrification community right from the get-go. It's been a very exciting journey. I also am the editor-in-chief for the Transportation Electrification Society's community's newsletter, which is an online publication. You can check it out. If you Google TEC newsletter, you can check it out. Some of the articles, and it has more of a magazine flavor, so it's not written very technically. The articles are easy to understand. So we're here to support you and answer your questions if you have any. And thank you, Lynn.
Thank you, Sheldon. So the format for today's session is we will be doing an interview session with Lee and Sheldon. And as both have mentioned, we will have a live Q&A session at the end. And please just type your questions into the Q&A box throughout the session, and we'll try to get to as many questions as we can at the end. So a little bit about the TryEngineering Tuesday student resource. It resides on the tryengineering.org website under the Teacher tab. So at the top of your home page, you'll see a Teacher tab. The resource includes 4 sections: Explore, Discover, Inspire, and Share. And we're going to dig in a little deeper to each of these sections with Sheldon and Lee as we start our interview. So first we have the Explore section, which provides career connections and ways to learn about the topic. In this month's Electric Vehicles edition, you can learn how the future of electric vehicles just might be flying cars with the Smart Cities Guide. Let's talk with Lee and Sheldon to learn more about the work that they do. Lee, can you give us a glimpse into what you do?
Yes. As we all are on this webinar, we're engineers. Way back when I decided to become an electrical engineer and get the BS degree in electrical engineering, and went on to get a master's in systems engineering and backed up with a certification in project management. So those tools and resources allow me to work in a variety of ways to help companies design their manufacturing facilities and supply chains and infrastructure to create, build, and deliver electric vehicles. I'll leave the design of the vehicles themselves to people like Sheldon. I build the plants that people need in order to create products and technology for customers. So it's a chance to engage with a lot of people that are involved in how do we move from design to a finished vehicle that can be tested and empowered to provide a service and rewards to people worldwide. And we do that through the types of engineering that I have done in my career. I also use the skills that I've developed and the tools I've created over the years to bring people together that want to add together various skill sets in order to create a working manufacturing plant or the infrastructure that will connect modern day electric vehicles to the highway, to the so-called cloud, and to the Department of Transportation's infrastructure. So all of these millions of vehicles can be driven together safely. And we hope quickly in moving people from home to work and product from factory to customer. So I'm one of those guys in the background that makes all that work through our engineering knowledge, our systems knowledge, and that one last piece that you accumulate over a long, long time is the experience. And that's what customers and employers want from their engineers is the ability to know what you've done correctly so that when you work on the next project, you can keep your promises to your management and do it right the first time, on schedule, and under cost. So those are the skill sets that make engineers powerful and also employable in the days and years ahead.
Thank you very much, Lee, for giving us a look into what you do every day. I know I found it very interesting, and definitely what you do is a very important component in the development of electric vehicles. Sheldon, can you also give us a glimpse into what you do?
Sure, thanks, Lynn. Well, as I mentioned earlier, and as you as well mentioned, that I'm a professor of engineering at university in Canada. And like any other faculty member, most of my work deals with research and teaching. So I do a lot of research, especially with, but I should give you my background as well, because most of you are wondering, how does one become a professor? Well, so I did my bachelor's in engineering and my master's as well in electrical engineering, and then a PhD in electrical engineering. And then, of course, you have a decent amount of research and publications in the field, such as mine, transportation electrification, such as Lee and me. We've researched a lot in this topic and some of the bottlenecks. And then I was inclined towards, I got a lot of industry offers to work for industry, but I chose the academic path so that I can train students. So my primary job function is to train graduate students and undergraduate students. And by graduates, I mean master's and PhD students, as well as undergrad bachelor's of electrical engineering students. But more recently, engineering across the board. So we typically, teach courses at the undergraduate level, and my area of expertise is electric circuits, power electronics, electric machines, electric motor drives, all of the stuff that goes into an electric vehicle. I also teach elective courses and grad level courses, which is for masters and PhDs and senior level undergrad on design of electric vehicles, electric transportation, electric energy storage systems, renewable energy systems, and some of those up-and-coming, more, I would say, cross-disciplinary courses. And then I already mentioned about my research, as I said. Well, one more thing, we also do a lot of capstone projects. In the senior level undergrad, activity, we have a final year capstone project. So they do a whole year of a research kind of a project where they get geared towards either entering into industry or take the academic path and do a graduate level course, like a master's or a PhD. So transportation electrification being newish, it attracts a lot of attention from students, especially undergrad as well as grad students. Research is mostly industry driven. As I said, the questions are asked by the industry. As Lee said, we are not scientists, but we are engineers. So what we do is applied science. Most of our work is applied to a problem, to solve a real problem. And the real world problem could be, for example, in electric transportation with batteries and the range of batteries, electric vehicles not going too far, the health of batteries so that they don't succumb to fast charging and blow up. You may have seen electric fires on batteries, etc. So those are the type of solutions for the industry we prepare through my master's and grad student, PhD students, and also postdoctoral fellows. We do also hire a lot of research scientists from all across the globe. Currently, I supervise more than 100 students at the grad and undergrad level for research. So, and again, like I said, I also hold a research chair position for the government of Canada, which is federally funded. So I do a lot of federal research projects as well. So it's not just industry, but also the government. That in a nutshell is what I do.
Thank you, Sheldon. And certainly the work you do every day helps to engage and inspire students as they prepare to enter their careers in engineering. So I'm sure it's a lot of fun in your lab, and hopefully one day I can come and see what you do in person. So next we'll go into a little bit, thank you. We'll go into the Discover section, and the Discover section starts with a lot of fun. It provides hands-on design challenges, links to these items that you can do in a classroom or in a home. And in this month's issue, you can have fun driving around in an electric car using an app that we provide the link for, or you can learn how to build your own electric car. So let's see what activities in this section are favorites of our engineers. And Sheldon, I'm going to start with you on this. As you look at that section, what do you find is your favorite activity in this section, or do you know of an additional one that we don't have, and why?
Yeah, so in terms of hands-on activities, most of our work is hands-on, as you know. I have several labs. Students come in even from high school during the summer when they're not at school and do science projects with us, and we're happy to help. So some of the work related to, for example, the most fun activity is, we did in charging a drone. A drone wirelessly charging from a spot charger. So a drone comes in and charges on a wireless charging pod. Just like, if this was a real opportunity to interact with you, we would have demonstrated a Tesla coil. For example, we have the Tesla coil from the 1900s, 1950. It's an analog system. We have a bulb, and you'll see it in the video, the YouTube video that I provided the link for. If you actually hold it close to the power source, you don't need, you can actually see the electric discharge happen, right? And the bulb lighting up. So a light bulb lighting up from a wireless power transfer. That's really fun. And then the offshoot of that was to charge the drone. Now, there has been issues, and we've been working with the Department of National Defense up in Canada to increase the range of drones and electric aircraft. And this can be done by wirelessly charging electric aircraft, just like you would do mid-air refueling. Think of it. If you're in flight and you lose charge in your batteries, you can have another mother drone or a mother ship come in, mother flight, and actually hover across or over the flight, right? Actual aircraft. And then you're wirelessly transferring power to the aircraft that is performing the mission. So that's what we've been doing with the Department of National Defense, and a lot of hardware goes into that. So that's a fun activity we do almost for several applications, as I said. More recently, we've been working on marine transport as well. We worked with rail transportation in the past. So yeah, wireless charging is catching on, and that would be truly autonomous, right? Because autonomous or driverless vehicles is coming. So that gives an added advantage for autonomous vehicles so that you can wirelessly charge them. So that's one example that I, off the top of my head, among many.
Great, thank you, Sheldon. And let's find out what Lee's favorite activity is in this section, or if he's got others that he has in mind, and why.
Well, a lot of things that I do now at my point in my career is I communicate with people who want to know more about where to go to school, more about what do I do if I become a electrical engineer, more about how do I go find jobs after I get my degree. So we as a volunteer for the IEEE, we try to make sure our members have the network, the knowledge, and a bit of the experience in which it takes to go find a job and deliver a job. If you go to the main IEEE site, there's all kinds of training that can empower people who have knowledge on one hand, but needed an idea and some direction of what to do with it after graduation. So those are the things I enjoy doing, along with helping my clients understand what it takes to build a large manufacturing plant and equip it with the supply chains, the equipment, machines to actually make an electric vehicle, no matter what it is. And so it gives me a lot of continuing hands-on experience and the rewards with knowing we can build something. And at the same time, in the evenings and weekends, work with students to empower the next generation to do the things that they'll be required to do in order to keep the world moving towards a electric, and we need to say another word a bit more, connected world in which all these vehicles can seamlessly work alongside each other to get from point A to point B.
Great. Thank you very much, Lee. Appreciate that. And next, we'll talk a bit about the Inspire section of the student resource. And this provides opportunities to make a difference. And this month's issue, you can learn how Go Baby Go is changing the lives of special needs kids to explore the world with modified electric toy cars. Lee, I'll start with you. Can you share a story of how you were inspired to pursue your field?
Well, you're inspired by teachers, basically. And my favorite teacher when I was growing up was my 8th grade science teacher. And that was before the current world of electric vehicles, but she did have experiments and things that gave us an insight into what makes a motor work, what makes a control system work, how does it all fit together with what was just happening then, which is called software, to create an automatic machine that can do something not only in a manufacturing plant or on the road, but out where people are, where they're learning, where they're doing work, where they're playing, all the things it takes to turn engineering and science into practical products and even services that can then be used by adults, kids, and also the special people you just mentioned that need a little extra help to be mobile or to connect to a world around them through keyboards, control panels, all sorts of user interfaces that can help a handicapped student do things in a more normal, natural way. So if you look at what engineers have done, and you'll see a lot of that on the Transportation Electrification page, you'll see projects where engineers take time out of their life to create electric wheelchairs, electric apparatus that can help people be mobile. And now today, those electric wheelchairs are becoming more and more autonomous because some students need almost complete support in order for the vehicle to take them to a classroom or to the school that they go to, and just fully empower them to move from here to there, and also set up and utilize things like the family vehicle or go in the door of the school that they attend. So there's a lot of projects like that that go on in order to equip students to make sure they can fit into a world that is very mobile and requires technology and special people to do things with the technology in order to be a fully fledged working citizen.
Great, thank you. And I'm going to throw a second question out at you.
Okay.
Do you have any ideas how students might give back to their community?
Well, we all have an ability to learn, and then what we learn, give back to someone who needs some help. The student that perhaps is in an electric wheelchair, well, with the knowledge they've learned, they can help the next person prepare for and adapt to become, a working part of humanity. So, it's the sharing of knowledge from one person to another, and that help that gets people ready to do things they thought they might otherwise never be able to do. So we empower individuals, we empower teams of people, and we train different kinds of people to come together and work on projects that go for a common goal of building something, or like the word says, inspiring people to be very active in the knowledge they can gain and then give back to the world.
Thank you very much. And Sheldon, I'm going to ask you the same two questions. First, can you share a story of how you were inspired to pursue your field?
So that's an excellent question, and I echo the same sentiments as Lee, in that we did a couple of projects through capstones. It started from a small project, right? So undergrad students doing a wireless charging project. Well, I have to apply this, right? So, and me coming from, Asia, India originally, when I was in high school, I saw a lot of wires, laptops, and a lot of wires plugged in to walls. If you go into, a room, if you have 4 or 5 members of the family using laptops and phones charging at the same time, you have a lot of wires all around the place with limited area to move. So when we got wireless, we started thinking of this whole new dimension, right? So smart cities, smart homes, smart offices with no wires. Imagine walking into an office and you just charge. Your phone just charges. You don't even have to think about it, right? Your laptop's in your backpack, you can charge. So that is really inspirational. The most inspirational thing that we did was exactly what Lee mentioned, was for old age homes. So the region of Toronto where we live in is called the Durham region. As you know, the Greater Toronto area, if you know, may or may not know, for those of you from within the GTA, the Greater Toronto area is divided into 7 regions, and we belong to the Durham region. So our region is called the Durham region, and in the Durham region, it's known for retirement homes and so on and so forth. So when we actually embarked on this project, we thought of wheelchairs, and we thought of autonomous wheelchairs. So the user doesn't have to do a thing, and it's electric, and it charges by itself. The other cool project we did, so undergrad students were really excited, and we actually tested the retirement homes, and it was a success. And some of them even wanted to just buy it off of us. So some of the students actually graduated, and now, in fact, have their own businesses. So it's a spin-off of what they did as a capstone, as it was in a bud. Now it's flourishing. That was one, and then the other one we did was very inspirational, was e-bike. Again, for the aged or special needs persons who can encourage them to be more healthy. So they buy bikes, but they're electrically assisted bikes. And so, so they do get the exercise, but they also get that additional electric assist if need be. So we built an e-bike from scratch, and again had it charge at docks, wireless charging docks. So you don't have to think of charging anytime. And that's something we've also demonstrated at our university on campus through wireless charging docks. So those are some of the things, in terms of projects that we basically did, which are quite inspirational for the students and also for the user.
Thank you. And do you have any ideas for students to give back to their communities?
Yes, so definitely. Both these projects, as I said, turned into spin-off companies. And so the students actually recruited many of our own university students as well as people from across the globe. And once they do that, they improve the economy of the region and the city and the country as a whole. So they've been doing that, in fact, quite a lot. Some of my grad students, as well as my senior undergrad students whom I've taught, they drew inspiration from my teaching courses. For example, some of my students even ended up buying electric cars after I taught them the course on transportation electrification. And then they send an email a year or two later and say, hey, Prof, we bought an electric car. How cool is that, I really got inspiration from your course, so on and so forth. So that was nice to know. But yeah, in terms of giving back to the community, they come back a lot, do a lot of projects with us, which are more geared towards, like Lee said, special needs students or special needs people, old age homes, facilitating. So a lot of the spin-off from the university or from an idea that was generated from the university project, they've built companies out of it. And so that's the best way that they can give back to the community being an engineer, specifically an electrical engineer.
Well, thank you, Lee and Sheldon, for interviewing with us today and sharing a little bit about what the work is that you do and some of the advice that you have for students as they look into what type of engineering career they're looking for, and especially if it has to do with electric vehicles. The last section of the TryEngineering Tuesday student resource is the share section. So we encourage you to share what you've learned when using the TryEngineering Tuesday resource or with any of the information you've learned in this webinar, whether it be at home, in the classroom, if you're a volunteer doing STEM outreach, any way that you utilize the resources. We'd like you to share that with us using the hashtag TryEngineeringTuesday on social media. And also be sure to share some photos of any of the hands-on design challenges that you decide to complete. So next we're going to step into our live question and answer session. Let me take a look here at some of the questions we've had that have come in. Okay, the first question is, hang on one second. Okay, so Sheldon, I'm going to throw this one out at you because perhaps in your research that you've been doing, you have some input on this. They're asking if we continue to charge electric vehicles using thermal power, then what will happen with the carbon footprint of electric vehicles?
Excellent question. That's a great question. So what we've been doing recently also is looking at solar power, right? Trying to go off the grid, right? So that's something that we've been really looking at seriously. Instead of burning power, instead of burning electricity someplace or burning fuel at the generating end, what we're trying to do is a lot of local generation through renewable electricity, such as solar, wind, fuel cells, etc., and trying to charge electric vehicles that way. And that, of course, is a bigger benefit than actually charging off the grid. And of course, the future, the uptick is going to go almost 5 or 6-fold in terms of electric vehicle usage the next 5 years, specifically in North America, right? Europe have already demonstrated a lot of renewable energy-based charging. North America is catching on. So has Asia. Asia, China have already developed renewable energy-based chargers as well. So that's something that we're looking at. Hopefully that answers that question.
Sure, thank you. Lee, I'm going to throw one at you. Someone's asking, what is one piece of advice you would tell a middle school or a high school student who says they're interested in engineering, but they don't know how broad the field of engineering is?
Well, the answer is pretty much that standard answer you get regarding today's education curriculum. Math, science, whatever your language is, learn how to write with it, create it. Those are the fundamentals to university science and engineering courses. So you've got to have a foundation in math, science, and English, or whatever your language is. So, and the place to do it is starting in grammar school. The grammar school kids don't realize how important even the math and science they're learning at that age, but that's where the parent comes in. That's where the local teacher comes in to inspire them to, keep doing the math at the grammar school level, because it's going to come together, and they'll see how in the high school and certainly university programs, how those equations you had to learn way back when equal how to design something, how to build something, how to automate and control something. So you got to have a proper sequence of the basics through middle school and high school to get to the place where you can learn the applied technology or develop the technology that is needed to become an engineer or a scientist. So I guess one more thing is, like I mentioned about my 8th grade science class, is go find a mentor. The mentor could be a parent. The mentor could be any teacher along the way that really makes you listen and think about things. Or it could be, someone who runs the science club at your school. So get a mentor, learn the basics, and your guidance counselor will help you pick the right courses to take in what order. And organizations like the IEEE, through TryEngineering and through the website that we're going to tell you about in a moment, you get to meet other people that can help you with a question or be that mentor.
Thank you. We've got another question that's come in. I'm going to throw this to you, Sheldon, because it's sort of education-based. So someone has, I believe they have a PhD in analog electronics. So they wanted to have an idea of how an electronics engineer factors into working in electric transportation.
Good question. So, of course, there's a lot of electronics that goes into electric transportation. My field is power electronics, which I deal with high power devices such as IGBTs and MOSFETs to build inverters and DC to DC power converters that go into electric vehicles that power the motors that he was talking about, right? So to drive the electric vehicles. So that's a lot of power electronics. There's also electronics that goes into battery management systems to give battery or to keep the battery safe on electric transportation. Charging of electric vehicles, again, is the power electronics, where you interconnect with the grid. So the grid charges the electric vehicle battery or a renewable energy source, as I mentioned, to keep it green and clean. Up-and-coming technologies such as solar, wind, fuel cells that can charge electric vehicles off of the grid. So that's all the interfaces, DC to DC power conversion, a lot of the conversion to electronics, control systems. So again, analog electronics, power electronics plays a vital role. Also, analog control systems built by analog electronics that can be handy. Microcontrollers, digital electronics, so on and so forth. So those are all interface. And I would like to also add to what Lee said, in terms of the engineering these days, the way I've seen it, I'll have a lot of automotive engineers, a lot of mechanical engineers interested in electric vehicles as well. So we've been teaching them a lot of electronics and basics as an elective, so that they are now ready to embark on the electric vehicle or electric transportation industry to get a job. So that's the new wave, where there's a lot of multidisciplinary teaching and learning going on in engineering. So that's something to keep in mind. So analog electronics is pretty much everywhere in terms of building an electric vehicle, especially at the component level. Hope that answers your question.
Thank you, Sheldon. We've had a question come in that I can certainly answer. Someone's interested in knowing how often the TryEngineering Tuesday student resource comes out and how many past issues we have. So the issue comes out usually the first or second Tuesday of the month, depending if a holiday falls on the first Tuesday. So that's why it might get bumped to the second Tuesday, like what we've done here. And we have had 3 past issues. So we've had ocean engineering, aeronautical engineering, and photonics. So again, on the tryengineering.org website, you can click on the teacher tab and see all 3 of those past events, and you can also watch the on-demand version of the webinar. And today's session will also appear on there as well. So Lee, I'm going to throw a question at you. What do you like most about your job, and what do you like least?
The biggest thing I like about my job is meeting people. And in the things that I create and the things I build, I get to meet people all over the world. Different languages, different kinds of people. It's all interesting, and it's fun. And I learn from every single one of them that I meet.
And what do you like least?
There's only 24 hours in a day, because like Sheldon says, while you're doing one thing, it's keeping you from, in your own way, learning more so you continue to have the value as an engineer or a scientist. So I have to do a lot of time management and make sure that I'm learning at the same time I'm doing.
Thank you very much.
I guess that's why I became a project manager.
I'm sure that is why. And that's where your best skills are. And Sheldon, I'm going to ask you the same questions. What do you like most about the work you do, and what do you like least?
Yeah, so from an academic standpoint, being a faculty, a professor, I love educating, right? That's what I love doing. I had opportunities when I graduated with a PhD to work in the industry, but I instead chose academia, where I could do some research, real-world problem solving, working with industry, and likely I love meeting people. That's a network where I build my industry connections. IEEE gives us a lot of opportunity across the board, not just academia, but also industrialists and government people to come attend IEEE conferences. And that's where we meet so many experts and we get to learn. So I love most about this job is what I love is learning at the same time. So not just imparting knowledge, but what I do is also from my students, quote unquote, I learn a lot. And so I keep myself abreast with new technology. Being a professor, now of course it's difficult to read. We do read a lot, all of us do. But our students are the primary source of education for us, believe it or not. And that starts from high school. Like I said, in the summers, I have high school students come in and do science projects. And I get to learn so much that what is being taught in the curricula in school. So right from there all the way to postdocs and research scientists and visiting professors from across the globe. So it's a bi-directional education information exchange. So it involves people, education, all the good stuff, all the fun stuff, real-world problem solving, working with industry. And just like Lee, I would say the thing that I least like about my job is time, especially these times, the times that we're going through. Most of our conferences have shut down where we can't meet people, we can't meet each other, we can't have a meal together, we talk about technology, we talk about our projects, forthcoming plans, so on and so forth at IEEE conferences due to the pandemic, right? And it's a global pandemic. It's unfortunate our friends and colleagues from across the globe can travel to the United States or Canada or vice versa. We can't travel. So that's really something, time, of course, is of the essence. But, under the circumstances, I really don't like that too much. And I hope that, clears away soon. Like this TryEngineering webinar, we have to do it online. There could be so much more that we could demonstrate. You guys could come visit our lab. So much of activity, fun stuff we could have done if it was in person. So yeah, I mean, but generally speaking, it's more fun than not.
So I've had a bit of a challenging question that's come in, Sheldon. I'm going to throw this your way because it's something you might have experienced in your research work. And so in your opinion, how can batteries be better controlled so that electric vehicles aren't as vulnerable?
Well, that's a very key research question, and that's what we've been solving for the past, I would say, 20 plus years. My Canada research chair position is on electric energy storage. And so I'm looking at new devices, newer energy storage devices that can go on electric vehicles, and also solving current battery problems, such as range, right? So devising new battery management systems, what we call BMS, to sit on top of battery modules so that you can get extra range, extra cycles of charging and discharging. That's something very important that we've been solving. We've been successful working with industry in solving that problem of doubling the range for the same cost. And with industry, it's always about cost, right? You have a great idea, but if it's put to fruition, it shouldn't cost double the cost of the battery pack itself. So we really look at cost-effective solutions. Some of the solutions we've built is within a 1% cost of the battery pack. And that's just how stringent the industry is. So if you have a $100 battery pack, your solution of battery management to double the lifetime should be within $1. That's what it is, 1:100. So really it's very challenging within the 1% cost target. We've achieved that. In fact, more recently, up until a couple of years back, when I received my IEEE fellowship, I was nominated and elected as fellow, upgraded to fellow of the IEEE. My citation was electric energy storage for my contributions to electric energy storage. So that's the work, the kind of work that we are looking at. And industry and original equipment manufacturers, what we call OEMs, are now adopting this technology, which goes into electric vehicles such as the Teslas, the Nissans, the BMWs, you name it. And so we've had some of our patents that have been bought by industry across the globe.
Very good. So I think that about wraps, let me check the Q&A box one more time. I think that wraps up our Q&A portion of the event. And so just a couple more items.
Oh, very good.
Go
Thank
ahead.
you. I was going to ask you to put this up. For
So
those of you who want to learn more and meet people and grow in this field, there's a URL at the top of this slide, tec.ieee.org. Virtually everything we've talked about, you can find more about through the tabs on this one slide. This is our website for all things transportation electrification. Use it. And if you want more or have questions, you can ask there on this site, and you can reach people that are just like Sheldon and I, or even better. We're all there volunteering.
Thank you very much, Lee. So just a couple more items before we wrap things up today. For those who are teachers on the session today, we do have a digital badge that we're offering, and so there's a downloadable link when you go to the TryEngineering Tuesday page on tryengineering.org, so hopefully you have a use for that. And I wanted to mention our next TryEngineering Tuesday webinar will be on September 14th, and it'll be featuring solar power in partnership with our IEEE Power and Energy Society. And I want to thank you, Lee and Sheldon, for joining us today to share your thoughts and experiences in your work with electric vehicles. And we truly appreciate your time.
You're most welcome. We had fun talking to you and answering the questions as well.
Great. Thank you guys so much. We really appreciate it. To the audience, before you leave, please don't forget to complete our feedback survey via the teal survey tool at the bottom of your screen. Thanks, everyone, and have a great day.